Welcome to the St.Peters Engineering College, Department of Civil Engineering. Myself, Gajendra, Assistant Professor, Department of Civil Engineering. I'm going to be teaching the subject Surveying and Geomatics. And direction. And today's session, I'm going to be discussing about the direction measurements. So the direction measurements will be having, so the two measurements are there. One is linear and another one is angular measurements. So the direction measurements is going to be classified into linear and angular measurements. What is the linear measurements? So linear measurements is length, breadth, or width. Linear measurements is length, breadth, or width. Sometimes we'll go for the depth. Angular measurements is going to be called as angle. Angle between the two stations, angle between the horizontal lines, angle between the straight lines we are going to be getting. So why the angular measurements and why linear measurements will be required? So the main objective of the surveying is that, so you are going to be preparing a plan of the map. I want to draw a plan. So what are the data will be required? So the data will be required of the linear as well as the angular. Linear measurements will be sufficient enough to get that or to prepare a plan. Sometimes we will give the additional information in the form of angular measurements. Angular measurements is going to be measuring the angle between the straight lines. That is also is one of the additional measurement to go for a preparation of a plan or the map itself. If you take that if you take that the drawing, we are going to be preparing a drawing. So we are having that the one is the plan, other one is going to be called as elevation. Another one is going to be called as sectional elevation. So I wanted to prepare the drawing. So I require what are the types of the plans will be required. One is plan, second one is elevation, third one is going to be sectional elevation. For plan, what is what is the data in the data input is will be required. For the plan, we can able to see that length and breadth. I want to prepare a plan. I will require the length and breadth. Plan is we are going to be called as top view. So plan is we are going to be called as top view. Elevation is going to be called as front view. Elevation is going to be called front view. For any object, top, what are the measurement will be, we are able to see that one. That measurement is length and breadth. We can able to see that one. For the same object, I'm going to be seeing this is the pen. I'm going to be looking through that. The pen. What is the dimension will be there? Looking through the front. What is the dimension we can able to measure? We can able to get that one. Elevation is going to be called as front view. We are able to get the elevation. In elevation, we will get that length and depth. Depth or the height, length and height will be required. So that's why I want to prepare a drawing or I want to prepare a map. There is output from a surveying where I am able to get that the drawing or the map. I require linear measurements, length, breadth or width and depth or the height. So these three will be required. Then I can able to prepare a plan. That is the top view, length and breadth, elevation, that is a front view, length and depth or the height. And sectional elevation is that when we require for specific information, we will cut that the plan and whatever the view or whatever the measurements will be there that we are going to be preparing in the sectional elevation. Means we want to go for in detail information, we have to go for the sectional elevation. Means these are all three will be essential. We are going to be preparing a drawing. As a drawing for drawing. So that is we are able to get the measurements. So that is the way we are going to be getting that the linear measurements. Linear measurements will be comprised of, so one is going to be called as the horizontal measurement, another one is going to be called as angular measurements. Angular measurements are we can say is the direction measurements. Here angular measurements we are able to get directly from the theodolite. But here we are going to be using direction measurements is going to be called as a specific reference line. From that where I am able to get the direction. From that direction I am going to be calculating that the bearings. So that we are going to be from the bearings. From that we are able to get the included angles. So the angular measurements we are going to be getting that the indirect measurements by using that the compass. So now for this session I am going to be discussing about the direction measurements. So the direction measurements I am going to be using that the instrument. What are the instruments that I am going to be using is going to be called as a compass. And in this, there are the two types of the compass are there. One is prismatic compass and surveyor's compass. So for the direction measurements, I'm going to be getting that the fixed reference line is going to be called the direction. From that direction, I can able to get the bearings. From the bearings, I'm going to be deducing or I'm going to be converting the angles. So there's the angular measurements. I'm able to get that indirectly by using the direction measurements is going to be called as the instrument where I'm going to be using as compass. From the compass, I am able to get the bearing. From the bearing, I can able to get the angles. That's why angular measurements is going to be called indirect method. So indirect method by using the compass, we can able to get the angular measurements. What are the different types of the compass are available? One is prismatic compass, another one is going to be called a surveyor's compass. This will go in detail in the next steps. So first we'll discuss about what is meant by the meridian, what is meant by the bearing, and what are the designation of the bearings, what are the methods are available for the designation of the bearings. So then we'll go for the what is meant by the forward bearing, backward bearing, and what is the include angle, how we can calculate the include angle, and what is the local attraction, and then we are going for the declination and the dip. So in the direction measurements, we are going to be discussing about that the first one is going to be called as what is meant by the meridian. And types of meridian. What is meant by the meridian and types of the meridian? What is meant by the bearing and types? Then designation of bearings. Designation of the bearings. Then forward and backward bearing. Then measurement of included angles. Then local attraction. So in the direction measurements, first of all, so we discussed about what is the instruments that we are going to be using for the direction measurement. Then after understanding that the instrument, then we'll go for the definition of meridian. What are the different types of the meridian? Bearing, types of the bearings, designation of the bearings, forward and backward bearing, measurement of included angles, local attraction, then what is meant by the declination, and the what are the types of the declination, and finally we are going to be discussing about the dip. So this is about the direction measurements. So in the direction measurement, the instrument is compass. So in the direction measurement, I want to measure the direction. So what the instrument is available is going to be called as a compass. In general, we are going to be using the compass for the navigation purpose itself. So that itself is going to be giving as a north direction. So north, south, east, and west. In which direction? So the ship has to be moved in the navigation, because we don't know about the sun. So where it is going to be, sun is going to rises and sun is going to be rest. So sun is going to be a rest. So based on that one, we are able to get that the so north, south, and east, west. But we cannot able to find that the sun. So then we'll see that the compass is going to be helpful for navigation in which direction we are going to be moving. So that is the compass we are going to be, general compass we are going to be using. So here in the surveying, we are going to be using the prismatic compass and surveyor's compass. So prismatic compass, in general, almost all the direction measurement is going to be given by the prismatic compass, because it is going to be giving from 0 to 360 degrees. So that is the, so the bearings is going to be varying from 0 to 360 degrees. So we are going to be using for the almost all in the compass surveying, we are going to do prismatic compass. Surveyor's compass also is going to be available here. So the minimum reading is 0 degrees and maximum reading is 90 degrees. This is going to be based upon the quadrant. So because total 360 degrees is going to be divided into 4 quadrants. So then we are able to, from the measuring the bearings from the north direction, similarly from the the south direction. So that is going to be called a surveyor's compass. But for the larger surveys, we are not going to be preferring for the surveyor's compass. Larger survey, we are going to be using always prismatic compass, because it will be having the various features to measure the bearings instead of the surveyor's compass. So surveyor's compass will be handheld instrument, and as a prismatic compass, we had to be provided the tripod stand. Above that one, we are going to be centering and leveling, and we can able to take the bearings. So that is the directions. We are going to measuring the directions. That direction is going to be called as a bearing. From the bearing, we are going to be finding out that the angular measurements. So this is about the common. So how we are going to be measuring the direction by using the compass. So now we'll go for one by one, because the compass surveying. So we are going to be preferably we are going to be using for the large area to be surveyed. In case of in previously we discussed about the chain surveying. Chain surveying will be used for the smaller boundaries, and also it is going to be called as no disturbances will be there. So the less the smaller areas we are going to preferring for the chain surveying, because we are going to be using the instruments is chain and tape. So that will be a flat ground or flat terrain, and also it is going to be suitable for smaller boundaries. If you go for the larger boundaries, so then in addition to the chain survey means you are going for the linear measurement by using the tape. In addition to that one, we had to be get the angular measurements also. So that is the indirect way of angular measurements we are going to be getting from the compass surveying. So compass surveying we are going to be using if you are given area or the larger areas to be surveyed, then we will go for the compass surveying. So in addition to that, the linear measurements by using the tape. In addition to the tape, we will go for the compass surveying by using the prismatic or surveyor's compass. We'll get the directions. From the directions, we're going to be getting the bearings. From the bearing, we are able to get the included angle. This is because the sequence of measurements we are going to be getting from the field, and we are going to be converting into the included angles finally. So then we'll go for what is meant by the meridian. So in this, we are having that the magnetic meridian, true meridian, magnetic meridian, arbitrary meridian. So I want to get the direction. Meridian is going to be called as fixed reference. So fixed reference line or the plane, fixed reference plane. So that we are going to be called as meridian. What is my fixed reference point? What I am going to be considered based on that one, the meridians are going to be classified. True meridian, magnetic meridian, and arbitrary meridian. In true meridian, I am going to be taking that north and south poles of the earth. Line passing through the north to south pole or intersection of the points north and south poles, that is my reference point. That then I am going to be called as a true meridian. North and south poles as a reference point. North and south poles of the earth on the earth we are going to be considering as a reference point. That fixed reference point I am going to be called as a true meridian. True meridian is going to be called as north and south poles of an earth on earth. So that is going to be called as true meridian. That's why the name is going to be called as true meridian. It is not going to be variation. It is not going to be changes. It is going to be constant at any place. That's why north and south pole I am going to be taking as a reference point, fixed reference point. From that one I am going to be measuring that the direction is going to be called as a true meridian. From the true meridian I am going to be getting the bearing is going to be called as a true bearing. From the north and south poles I am going to be measuring that the bearing I am going to be called as a true bearing. From the true meridian I am going to be getting that the true bearing. This is my fixed reference point. From this, I'm going to be measuring is going to be theta. Theta is going to be called as the true bearing. So means I'm going to be taking that north and south pole. North and south pole. North and south pole is the reference point. From that north and south pole reference point, I'm going to be taking the bearing. So that I'm going to be called as a true bearing. Similarly, next is going to be called as a magnetic meridian. So similarly, next second one is going to be called as magnetic meridian. Here, so I'm going to be taking the fixed reference point is going to be called as magnetic needle. So magnetic needle is going to be suspended freely. So that direction is going to be is going to be called a fixed reference point. Magnetic needle suspended freely. So without deviation. So that is going to be freely suspended magnetic needle. So direction gives so that taken the direction that we are going to fix a reference point that we are going to call as magnetic meridian. So then the magnetic needle taking as a reference direction. So then from that I am going to be measuring the bearings. I'm going to be called as magnetic bearing. Magnetic meridian. With the magnetic meridian is going to be called as magnetic needle is going to be called as a reference point, or magnetic meridian is going to be called as a reference point. From that I'm going to be measuring the bearings is going to be called as magnetic bearing. Similarly, this is going to be called as magnetic needle. So freely suspended magnetic needle taken as the reference direction, then we are going to be called as a magnetic meridian. Then finally, so arbitrary meridian. So arbitrary meridian is going to be called as arbitrarily. The term itself is going to be giving as meaning any temporary direction or any temporary line I am going to be taking as arbitrary meridian. That is going to be called as reference point, that we are going to call arbitrary meridian. Any temporary reference point, any temporary reference direction. For the time being, any direction where I'm going to consider as a reference direction, that way I'm going to be called as temporary purposes. So that meridian where I'm going to be called as arbitrary meridian. So with reference to the temporary direction or the temporary reference line, I'm going to be measuring the bearing is going to be called as arbitrary bearing. So true meridian, magnetic meridian, arbitrary meridian. With respect to the true meridian, I'm going to be getting that the true bearing. With respect to the magnetic meridian, I'm going to be getting that the magnetic bearing. With reference to the arbitrary meridian, I'm going to be getting that the arbitrary bearing. So bearing is going to be called as from the fixed reference point, I'm going to be getting that the angle that we are going to call as a bearing. You can say that the angle we are going to call as a bearing. From that the bearing, I'm going to be finally so they calculating or evaluating that the angular measurement itself. For the true meridian, north and south pole is a reference point. For magnetic meridian, so magnetic needle, freely suspended magnetic needle is a reference point. Which direction is going to be shows, that is going to be called a fixed reference point. Any direction, convenient direction we are going to be considered is going to be called as arbitrary meridian. With that, I'm going to be measuring is going to be called as arbitrary bearing. So this is about the meaning of meridian is going to be called as fixed reference point, and what are the different types of the meridians and what are the different types of the bearings we are going to be so measuring the bearings from the meridians. True meridian, true bearing; magnetic meridian, magnetic bearing; arbitrary meridian, arbitrary bearing. Then comes to the designation of the bearings. Designation of the bearings means how, in what way I can able to express the bearings. What are the different methods are available? So that is I'm going to be called a designation of the bearings. So first method is going to be called as whole circle bearing. So we are going to be called as WCB. Then quadrantal bearing. So designation of the bearing means how I can able to measure the bearings. What are the methods are available is going to be called as one is whole circle bearing. So WCB, quadrantal bearing QB. So whole circle bearing, this is the C, B, quadrantal bearing Q and B. So there the two methods are available to measure the bearings with reference to the fixed reference point, whole circle bearing and quadrantal bearing. So in what way I can able to measure the whole circle bearing? In what way I can able to use the quadrantal bearing? Whole circle bearing, almost all we are going to be using this system of the measurement of the bearings. We are going to be using with the help of prismatic compass. In quadrantal bearing, so we are going to be using the instrument is going to be called as surveyor's compass. If I am going to be using the surveyor's compass, I am able to get that the bearings is going to be called a quadrantal bearing system. If I am going to be using that the prismatic compass for the survey purpose, so then I am able to get that the bearings is going to be called as whole circle bearing. So then the whole circle bearing system. So then the whole circle bearing system used in prismatic compass. So why the name is going to be given as whole circle bearing? We are going to be taking that the circle. So starting from 0, and 360 degrees, 90, 180, 270. So in whole circle bearing means, because circle will be having the whole circle will be having, it is going to be varying from 0 to 360 degrees. The minimum is 0 and maximum I can able to measure is going to be 360 degrees. That's why the system we are going to be called as a whole circle bearing system. Whole circle bearing system. This method of measurement of the system we are going to be using in the prismatic compass. So here we can able to see that one. So this is line joining all these points. North, east, south, so this is my reference direction is north south, because whole circle bearing I'm going to be using with the magnetic bearing or the magnetic needle, suspended needle, north and south. North, the magnetic needle always shows that the true north. So north direction. From the north I am going to be measuring. This is my line, survey line is going from A to B. So then I am going to be measuring the bearing is theta. So measuring the bearing is theta, or theta equals to 60 degrees. So A to B line with the magnetic north is going to be called 60 degrees, or I'm going to be measuring like this. So this is going to be called as 110 degrees. So this A to C is 110 degrees. A to D, I'm going to be measuring from north only. So this is 240 degrees. So 240 degrees. Then from north only, I'm going to be one more line I'm going to be measuring. So this is 310 degrees. Means from that taking the reference point. So first I'm going to be measuring. So first I'm going to be measuring. This is the first point. A to B, theta 1 equals to 60 degrees. This is my north point. So this is the 60 degrees, A to B. Similarly, line A to C, this is my north direction. This is 110 degrees. From magnetic north, I'm going to be measuring the line A to C. So my bearing is 110 degrees. And next is, this is magnetic north, A to D. So this is 220 degrees. A to B, A to D. So this is A to D is 220 degrees. Similarly, A to E, this is my magnetic north. I'm going to be measuring from like this. So this is 330 degrees. 330 degrees. So like that, it is going to be your bearing is going to be whole circle from the this reference point. I'm going to be taking as a magnetic north. From the magnetic north, I'm going to be measuring. So first you take the AB is going to be 60 degrees from the north, and then the next line A to C is 110 degrees. How I'm going to be measuring? You can able to see that one. Then next one is A to D. So in 220 degrees, then A to E is going to be called 330 degrees. Each and every stage, this is the first diagram, second diagram, third diagram, and fourth diagram. So in each and every diagram, I'm going to be measuring my bearing, that is the direction from magnetic north. My reference direction is magnetic north. From magnetic north, I'm going to be measuring that the 60 degrees, 110 degrees, 220 degrees, and 330 degrees. So completely, each and every time I am going to be measuring from magnetic north, my direction is A to B, my direction is A to C, my direction is A to D, my direction is A to E, each and every time. So I am going to be measuring from magnetic north. That's why it is going to be called a whole circle bearing. So it is going to be varying from 0 to 360 degrees. Your whole circle bearing will be minimum will be 0 degrees and maximum will be 360 degrees. So next method is going to be called quadrantal bearing. So this quadrantal bearing I am going to be using in the surveyor's compass. Quadrantal bearing system I will be using in the surveyor's compass. So in quadrantal bearing system, how I can able to measure that the directions from the fixed reference point or the magnetic north. Here also I'm going to be taking the magnetic north and south. So I'm going to be taking as reference directions with reference to that one, whichever will be the nearest to one, whether it is going to be nearest to the north or nearest to the south. I'm going to be measuring the bearings is going to be called as quadrantal bearing system. Each quadrant, so total 360 degrees, I am going to be making it the 4 quadrants. This is the first, second quadrant, third quadrant, and fourth quadrant. So in first quadrant is 0 to 90. So then 0 to 90 and 0 to 90. So in the quadrantal bearing system, the minimum angle or the minimum bearing I'm measuring is going to be called 0 degrees, and maximum I can go for 90 degrees only. In previous case, whole circle bearing, minimum is 0 degrees, maximum is 360 degrees. I'm going to measuring. That's why it's going to be called a whole circle system. And quadrantal system, the term itself is going to be giving you a meaning quadrant. In 0 to 90, minimum is 0, and maximum is going to be 90 degrees. Whether I'm going to be measuring from north or measuring from the south, So that is going to give you that the direction of your bearing. Direction of the bearing is which direction is going to be nearer, whether the north or whether the south. North south as reference point. From the north or the south, I'm going to be measuring the direction. So that is going to be giving as a quadrantal bearing system. Then we'll go for how the direction is going to be measured by using the quadrantal bearing system. So in the quadrantal bearing system, first is north, south, east, west. First direction I'm going to measuring is this is theta 1 degrees A to B. So my direction is A to B. A to B is the direction I'm going to be measuring from magnetic north, which that is going to be called the nearest one. Then how I can able to write as the quadrantal bearing. So now quadrantal bearing is represented as north theta 1 degrees east. North theta 1 degrees east means, so north to east my line is going, that is the direction is going. That's why I'm going to give north theta 1 degrees east. So this is in the first quadrant. So now, so another one, this is north, south, east, west. A to C. A to C is the direction. So then from the south is going to be, for the A to C, the south is going to be called the nearest direction. I'm going to be measuring theta 2. So then how I can able to write south theta 2 degrees east. South theta 2 degrees is east is going to be called as the second quadrant. In second quadrant, south is the nearest direction, nearest pole where I'm taking. From south to east, I'm going to be measuring as theta 2 degrees. So in the second quadrant, in this way, I'm going to be measuring in the second quadrant in the quadrantal bearing system. Next one is north, south, east, west. My line is A to C. I'm going to be measuring as theta 3 degrees. Next direction is A to C. So this here theta 3 degrees is my direction. I'm going to measure from the nearest point, nearest reference point is south. So that's why I'm going to write it as south theta 3 degrees west. So first one is north theta 1 degrees east. Second one is south theta 2 degrees east. Now is the first quadrant north theta 1 degrees east. Second quadrant southeast theta degrees. Third quadrant southwest theta 3 degrees. Like that, in quadrantal bearing system, I am going to be measuring that the bearings are with respect to the directions. Last quadrant is north, south, east, west. Now A to D is the line direction. A to D is the line direct. A to D is the line. So that is going to be direction is the direction bearing is going to measure from north direction. North is going to be nearer. So then it is going to be called as north theta 4 degrees west. So north theta 4 degrees west. First quadrant north east theta 1 degrees. Second quadrant theta 2 degrees east. Third quadrant theta 2 degrees west. So in the first quadrant, northeast theta 1 degrees. In second quadrant, south east theta 2 degrees. So third quadrant, south theta 3 degrees west. And last quadrant, fourth quadrant, north west theta 4 degrees. Theta 3. These are the how we are going to be measuring the quadrantal bearing system. So now then if I am going to be changing from whole circle bearing to the quadrantal bearing system, whole circle bearing to quadrantal bearing or reduced bearing. So now line is A to B, theta 1 degrees. Now whole circle bearing is equals to theta 1 degrees. Then reduced bearing, quadrantal bearing, or reduced bearing. I'm going to reduce it to the quadrantal, quadrantal bearing is going to be reduced. Whole circle bearing is good. Then what is going to be having? So your reduced bearing equals to north theta 1 degrees east. Means so your magnitude is not going to be changed. Suppose WCB theta 1 equals to 60 degrees. Your WCB whole circle bearing equals to 6 degrees. Your reduced bearing equals to north 60 degrees east. Means it is not going to be changes. So numerical the magnitude is not going to be changes. So direction I am going to be giving a northeast direction. WCB is going to be 60 degrees. Your reduced bearing is going to be called as it is north 60 degrees and east. So this is how we are going to be converting from whole circle bearing to the quadrantal bearing or whole circle bearing to the reduced bearing system. Similarly, if it is north A to C, so so my theta 2 equals to 110 degrees. Theta 2 is going to means whole circle bearing equals to 110 degrees. So from the north direction A to C. So I want to convert that north south east to west. So this WCB 110 degrees, I want to convert it into the quadrantal bearing system. How I can able to quadrantal? So quadrantal bearing system always is going to reference with the northeast or southeast. So I have to reference with the southeast, south and east. So my direction is going to be called as southeast. So here I want to measure. This is my the QB quadrantal bearing. So this is my quadrantal bearing. But I am getting that the whole circle bearing is going to be 110 degrees. So then the formula is going to be called as 180 minus 110. So 180 degrees minus 110 degrees is equals to 70 degrees. So this is your quadrantal bearing is going to be called as 70 degrees. Now south 70 degrees is east is my quadrantal bearing system. So if it is your whole circle bearing will be in the second quadrant. So our example is 110 degrees. How I can get that the reduced bearing? So I am using that formula is 180 degrees minus WCB. So this is the formula I am going to be using in the second quadrant. If it is your whole circle bearing will be in the second quadrant, and I want to get the reduced bearing is the southeast, then I have to be use the formula is 180 degrees minus WCB, or otherwise 180 degrees. The total angle is 180 degrees minus square. So this one minus 110, I am able to get this because quadrantal bearing is from southeast I have to measure, but my whole circle bearing I measure from this whole from the north direction only I measured. So that's why I'm going to be taking as conversion is going to be called as the 180 minus 110, 70 degrees. Now south 70 degrees east is my reduced bearing. That's the corrected one. Then if it is there in the third quadrant, now my whole circle bearing is 210 degrees. What is my reduced bearing? What is my reduced bearing? So reduced bearing is always reduced bearing or quadrantal bearing is always southwest, south to west. In third quadrant, always it is going to measure from south to west. Now what I have to do is WCB minus 180 degrees. WCB minus 180 degrees is my so the quadrantal bearing system. WCB is 210 minus 180 equals to 30 degrees. So my reduced bearing or the quadrantal bearing is south, 30 degrees is west. How I am able to get it? This is the formula I am going to be using. Whole circle bearing minus 180 degrees minus 180 degrees. I can able to get. This is the thing I had to be get that. So this is my quadrantal bearing. I had to be get. Whole circle bearing is going to be called 210. So 210 minus 180. I am able to get this whole circle quadrantal bearing system. So this is the formula I am going to be using. WCB minus 180. So is geometrically we can able to calculate it how the what is the what from here to here we know that one is going to be called as 180 degrees. From here to here we know that 210 degrees. 210 minus 180 degrees is going to be. So this is in the form of I'm going to use the equation WCB minus 180 degrees. So in the first quadrant, if I'm going to be taking the first quadrant, so your WCB equals to quadrantal bearing. If I'm going to be getting the second quadrant, so your quadrantal bearing is so 180 degrees minus WCB. If it is in third quadrant, your quadrantal bearing is WCB minus 180 degrees. Similarly, if I am in the fourth quadrant, this is my line A to E. So A to E is 320 degrees. So my whole circle bearing equals to 320 degrees. What is the quadrantal bearing? So quadrantal bearing is this one. This is the quadrantal bearing. So this is the question mark. This is the question mark. How much is this one? So this one is so I know that total is 360. 360 minus my whole circle bearing. Quadrantal bearing is 360 minus WCB. So your quadrantal bearing is 360 minus 320. So your quadrantal bearing is 40 degrees. So 40 degrees is north to west. So my quadrantal bearing is north 40 degrees west. Quadrant bearing is north, 40 degrees is west. So this is the in fourth quadrant. In fourth quadrant is 360 minus WCB. So in the fourth quadrant, quadrantal bearing equals to 360 degrees minus WCB. So this is the formula we are going to be using. Formula we are going to be using. I'm going to be converting one system to the other system. So we know that the WCB, what is the quadrantal bearing? So WCB is known. WCB is known. How I can able to measure the quadrantal bearing? WCB took first quadrant WCB is and quadrantal bearing is the same one with respect to the directions. Quadrantal bearing is in second quadrant. Quadrantal bearing equals to 180 degrees minus WCB. In third quadrant, WCB minus 180 degrees, and fourth quadrant 360 minus WCB. So this is about how we are going to be converting from one system of bearing, one system to the other system. Whole circle bearings to the quadrantal bearing system. Similarly, if the quadrantal bearing system is going to be given, how we had to be converted into WCB. This is the formula we are going to be same formula we are going to be using to get that the whole circle bearing system or the quadrantal bearing or the reduced bearing system. So in the next session, we will go for to discuss about that so how we can able to finding out that the forward bearing and backward bearing of a line. From that, how I can able to calculate the included angle, how we can able to get the included angle, what is meant by that the local attraction, what are the causes for the local attraction, and then so what is meant by the declination and types of the declination, or what is meant by the dip. So next session we are going to be discussing about that the forward bearing and backward bearing, measurement of the included angles. So then we'll go for the local attraction, magnetic declination, and the dip. So thank you.